Okay, all. Thank you for joining today's call. We will get started. So we see that there's a lot of people on the call today, very excited. So moving forward, so I'm just going to share some general instructions before we start with the actual webinar. We have here the presenters, Fiona, John, and Tobias as well. And also we have Maria Gilker. She is part of our GMG staff. So if you have any questions or any type of technical issues, you can also ask me or Maria. So some instructions for today's call. So first of all, speak and engage in the conversation. So if you have any questions at any given time throughout the presentation, you can always go ahead and raise the hand. That's a capability that you can see when you click on more in your screen. Then, or you can also just go ahead and unmute yourself and say that you have a question. There's also a capability that you can go ahead and ask the question directly in the chat of Zoom, and we will have someone from our GMG staff answer that question for you. Then again, we have that Zoom keep the microphone muted, meaning that, as you guys know, now that we are all been facing this new virtual reality world, we have virtual environment world. We have all experienced that there are background noises in our houses from time to time. We have experienced even people having their kids or roosters at some point. And just to keep in mind that it will be important to keep ourselves muted if we're not asking a question or engaging in some sort of conversation, just to be sure that all of us are concentrated in the presentation. Identify yourself when speaking. So if you go ahead and are going to ask a question through the microphone, please go ahead and say your name first so we know who's asking the question. Stay focused on the virtual forum. So we might want to try to multitask, read our emails, but it's important that we keep this time to the presentation because we have very great information to share with you guys today. So it would be great if you guys are present to be able to get all of this new insight that you're going to get today. We highly recommend to use a headset or headphones as it usually provides a better audio for you guys and also audio for us to be able to hear you better. Raise the hand if you have any questions and enjoy, learn, and network. As you guys can see in the chat, we have a lot of mining professionals and related professionals of the industry today. So this is a great opportunity to share your thoughts, share what your company or organization are doing as well that it could relate to this topic today. So before we get started, I just wanted to invite you guys to the GMG workshops that are occurring on May and June. So for example, tomorrow we have the electric mine operational knowledge sharing platform. And here we have a couple others going on next week. As you guys can see, all our way from May and June, we're gonna have interactive workshops occurring. So please go ahead to our GMG group.org website and go ahead and check in events, all of our different workshops that are occurring this month and the next one, so you can enroll and start being part of change and innovation in mining. So now we will get started with today's presentation. So in our latest GMG series featuring John Lemon, Fiona Marburitz, and I'm sorry if I'm not saying your last name correctly, then you can go ahead and say it right, and Tobias Hartman. So they will be presenting about data exchange, OPC UA, and a common language for mining. So at the end of the presentation, there will be a Q&A period. So you can also ask questions at the end if you want to just wait until all the presentations are over. We will be monitoring the chat the entire session if you have any questions at any given point as well. For those that are not speaking, please again, go ahead and mute yourself. And you can send any type of message. It could even be just a comment on something that any speaker is saying, so we can also have a conversation going there. So if everybody can put themselves on mute, we will begin. John, on to you.
Thank you. A warm welcome to everybody. Let me start with our data exchange, OPC UA. Mining, as you see, we are 3 guys which will present this common language. Mrs. Mavroudis from ICOF also chair from our working group within Germany. Tobias Hartmann from the University of Aachen, Advanced Mining Technology, and myself, Jon Lehmann from the VDMA. First of all, let me introduce the VDMA. What's the VDMA? It's the most important association in Germany, in Europe as well, and we represent 3,200 member companies in the engineering industry. And we have 38 trade associations for the different branches and 6 regional state associations and international representatives like in Brussels, Brazil, China, Russia, and Austria, for example. An important task for us is the technical representation of interest. This involves that we identifying projects on the technical level together with our member companies, and we try to organize these topics or projects together within one association or like OPC UA and the whole VDMA. The VDMA covers the entire mechanical engineering sector from like agricultural machinery to woodworking machinery, for example. And let me take a look on OPC UA, Open Platform Communication, what's behind this and why do we believe in the VDMA with our members that it will be the future common language in mining. Let's see a short video about 1 minute about OPC UA.
What is OPC? OPC UA is an open standard that specifies information exchange for industrial communication, particularly on devices within machines, between machines, and from machines to systems in a convergence of IT and OT. It can be used with any software platform, Windows, Linux, Mac, Android, well, you get the picture. And this makes OPC UA scalable. From minimal embedded controllers to massive cloud infrastructures, even mobile devices. OPC UA is equally suited in a closed network or utilized via the internet. Don't worry though, security is baked into the protocol for access control, authentication, and encryption. Because of its flexibility, OPC UA has been widely adopted in industries like automotive, food and beverage, oil and gas, energy and utilities, packaging, building automation, and so on. So, as manufacturing moves into the Industrial Internet of Things Industry 4.0 realm, OPC UA is already poised to fulfill the requirements.
Okay, one important argument for us in the mining industry was that oil and gas industry uses OPC UA as well. So within the VDMA, we take a look on OPC UA and other standards, but which arguments lead us to this technology? Within the framework of Industry 4.0 or industry Internet of Things, smart mining, various approaches were tested and their suitability for future automation was evaluated. Automation Industry 4.0, smart mining, all of them require standardized interfaces to ensure communication between the different participants, for example, machines or superordinate systems. And we think the following reasons spoke for OPC UA. The requirements of the mechanical engineering, like communication on an open platform, security by design, or the support of different protocols will be met by OPC UA. And we have benefits for the mechanical engineering as well, that we have a manufacturer independent communication reduction of interfaces and supported protocols. And we think about plug and work, condition monitoring, and predictive maintenance will be supported by OPC UA as well. So let's take a look on OPC UA. It's not a new development. It's really a little bit, it got a history, and the definition and the framework was developed from 2003 to 2009, and the final release of OPC UA was 2009. Then it seems to me important that from 2010 to 2012, OPC UA was standardized via IEC. So thus, it's now published worldwide, and it's regularly reviewed, because every standard should be reviewed at least every 5 years. So as you know, we need agreements on common standards in order to be able to leverage the advantages of automation, Industry 4.0, IoT, or smart mining. And today, OPC UA offers us open source and toolkits. You can adopt OPC UA without any membership. Certification for members and non-members are possible, and they have a strong IPR policy. What characterizes, in our point of view, OPC UA? We have one information model that's object-oriented, flexible, and extendable. We have, out of the box, two communication protocols, two communication methods, client-server and publish-subscriber. And a number of protocols are already supported, and the development on other protocols like TSN or 5G is currently being worked on. And security includes OPC UA directly. Why does the VDMA actively work on OPC UA with its members? We have 38 trade branches, as I have mentioned before, and each of them are discussing the advantages and disadvantages of Industry 4.0, Industry of Things, and so on. And they all need the information exchange in the processes and a language to understand each other unambiguously. So the colors of indicate the different status of work of the different associations. We have already released some companion specifications for the robotics, machine vision, plastic and rubbery machinery. There's a release candidate, for example, the weighing technology, and we currently have joint working groups with the OPC Foundation, like the glass machinery, integrated assembly solution, and our working group on mining. And more associations are discussing about OPC UA. And let me summarize our activities. We have a rapid increase of new OPC companion specification working groups. More than 18 sectors branches are under discussion, and 17 sector branches are really active in implementation. And we have, at the end, 26 OPC UA companion specification working groups existing, with more than 450 companies which are involved and drive the development of this standard. So, thanks a lot for your attention. So, let me hand over to Tobias to give you a deeper insight into OPC UA.
Yeah, hello everybody. My name is Tobias. Let me share my screen real quick. Yeah, hello from Aachen University, Institute for Advanced Mining Technologies. My name is Tobias Hartmann. I'm currently working as a senior engineer here at the Institute. And I will tell you about why we need or why we believe we need an open communication as an enabling technology for the mining industry of the future. First of all, let me introduce our institute real quick. Our Institute for Advanced Mining Technologies, we do research, education and transfer for a secure, efficient and responsible supply of raw materials through automation and digitalization of mining industry, of mining machinery and processes, and do all this work, of course, within the mining industry in a lot of different projects. Our research focus is along the data information value chain, where we always implement some kind of robust sensor technology, set up some kind of data transfer, digital communication, have some processing, if it's image processing or machine learning, in very, very different applications. And then at the very end, we always, together with our partners, create some kind of smart service. From that information we try to gather within the processes or the automation of the machinery. So when we're talking about mining 4.0 and digitalization, we think that this digitalization is actually an enabler for raising, on the one hand, the automation level and the process automation of up to entire value chains, and on the other hand, enables it to raise the knowledge level. As you know, in mining, there's always a lot of unknown, so a little bit more of gathering of data and evaluation of data can bring large advantages. So, but at the end, this automation of machinery and processes is highly connected to the gathering of the information, gaining knowledge about the process to be able to move to the next step of automation, and then be able to even gain more knowledge about your process or even about your entire value chain. And here, the key role will have machine to X. I call it machine to X. It can be machine to machine or to some supervising system or to some human. The communication will rise along these automation levels and along these knowledge levels, and will have a key role to reach the goal of autonomous and self-learning and also self-aware systems. And that is why we are very interested in supporting partners and OEMs and also the association in working together to establishing a common language for machinery. And that is also the most important point. We do often have like different kinds of machinery, and we look at their internal data. They have internal communication, of course, for control demands, control commands, or different purposes. And oftentimes we start connecting those machinery and somehow gathering the data that is very inhomogeneous. And what we see is that some of the companies gather that data, make it more homogeneous and evaluate that data and try to already get more value out of it. But there is still a large interoperability gap, not only in gathering the data and gaining information, but also connecting those machines, since they basically speak a different language. And if you would send the information of the one machine to the other, it would not be able to possible to automate a process between those two straight away. So what we want to establish here is a common language for those two machines, or that's a goal to reach. Make those machines structure their data in the same way so they can exchange data and information, also service-based, to raise the level of automation and be able to have them interact in some kind of process. And if we organize this in one specific way, this communication, that will enable to just exchange the machine, no matter what color the machine or the machine manufacturer prefers, or what internal communication the machine does, if we make it externally basically speak the same language. And if we have those two machines connected to each other, we can also bridge very easily the interoperability gap to other systems and make that data compatible and available throughout our process systems, process control, ERP, or some other new cloud services. And that would really help us enable technology development. And that's why we think we need an open structured way of communication, an open structured and standardized way of communication as a key enabling technology to further automate our processes, but also to optimize and gain information about our processes and just become that more efficient and more sustainable in our mining processes. So why isn't that already happening? What is so challenging regarding communication in mining? And as you know, we have a very complex and fast changing environment where we have a huge variety of machines in very different mines with very different processes, and the mines already often have their existing infrastructure that they want to continue using, and there's already something prepared that we have to integrate into our system, whether it is regarding mobile devices or stationary equipment. Overall, we just have a large variety of data and processes and existing systems and setups. So if we go through and try to list some requirements we would like mine communication to have, then of course I would first say it needs to be independent of some manufacturer and independent of the platform, so everybody could integrate it. So we needed to be able to access those protocols and those interfaces, and we need clear definition of what does a position look like, or what does this information look like, so that everybody understands what this data looks like, and that it's always structured in the same way if we have the same kind of machinery. And of course, it has to be extensible beyond the specification. In the specification, we won't be able to think of everything, so it needs to be extendable and of course scalable for a variety of machines. And we don't want it to be centralized. So it needs to be possible to send information in a decentralized way, so we get a good robustness of our system, so we don't have a single point of failure. And we can also decentralize our decision making. So if a shovel is interacting with a truck, we don't need the command control to make a decision on here. So the truck and the shovel, they can negotiate and make the decision themselves without that centralized communication. And I think this list, if we fulfill this list, there is an ability, whatever fulfills this list has an ability to become like a widely used and open standard. And it has to be widely used, because if we only look for like some niche solution, we end up where we are right now, where everybody is converting one data type into another and trying to integrate this system here and this system there. We only can get the value out of the common language when we have an open and commonly used standard. So, and we think that these requirements can be fulfilled by OPC UA quite well. And so we see that there is a great potential in the OPC UA, not only because it fulfills those requirements, but also because of its flexibility. OPC UA I recently read an article. It's the person said OPC UA is like a Lego box where you can take your pieces out and integrate your pieces into your communication system as you like. And if you look at the communication layers, the OSI model, then OPC UA actually only designs the top layers, and you can use any lower layer communication system as you like. So you can combine OPC UA with your Ethernet IP TCP, or you could even go for the future and change your network to 5G and use time-sensitive networking. And that is all is based. You can use all this as a basic for OPC UA, or it would be also even possible to combine the OPC UA session layer stack with some other application layers. For example, Modbus, if you say, okay, we create some parts of the language in OPC UA, but we want to keep those functions running, and then you only use the OPC UA security features. So it has a lot of potential also to not only use it by itself, but also to combine this Lego box with other systems. And when we speak of our mining companion specification, what we are actually working on, then we are always speaking of the application and the representation layer. So how do we represent the information of our machinery that in a standardized way that other partners in the process or in the supervising system can process that data, and always take into account when we create this specification together with the OEMs that we have the application in mind and not just transfer everything in an unstructured way. So try to make best use out of the system. Here I brought along some ideas how an implementation could look like. To come back to the example we just had, we of course can have a truck and shovel. They have their internal SPS communication, and then externally there can be an OPC UA server client system, and they can be communicating through your local WAN network. Or you could even use some public serviced network and send the information secured by OPC UA via the internet. Or if you have already the online connection, you would not only be able to run the process automation, but also integrate remote service and supervising system onto your local network and have some faraway machines and services that run with the data and do some services or request data for analyzation of your processes. So that is already all integrated into OPC UA, and that's why we think it is so strong. So let me summarize this. We think that OPC UA has the ability to bridging this interoperability gap in mining. And of course, if there's something follows OPC UA, the structural work we put into it with the OEMs, with our partners, can be easily transferred to other object-oriented languages. But right now we see that OPC UA is very strong, and that's also why we actively participate in the work on the companion specification that is led by the VDMA. And yes, we of course need all of you as partners, and we need a worldwide cooperation to make this the common language, and we would warmly invite you to participate. We also have a slide prepared later on when I've talked about our work in the workshops. And to come back to our data value information chain, we think that regarding the digital communication, that OPC UA really can bring the mining and the digitalization forward. Thank you very much. Thank you for listening. I think we might have some time for question and answers, but as already has been said, we also can answer questions at the very end in a summarized way. Thank you very much. And here's the link in a QR code to our institute's website. Thank you for listening.
Do we have any questions at the moment?
Okay, how are OEMs and manufacturers of equipment embracing OPC UA?
I'm not sure about the word embracing right now, but the VDMA is of course connected to a lot of those manufacturers and companies, and they are very curious about what they can do with it and what the potential is and how they could potentially create this, I call it language, create this language, and they're very, very interested and also join our workshops. We have, as we said, a companion specification already running with a few OEMs. And I think we also, this question can also be answered by Fiona Mafroudis, who will present a little what ICOF thinks of OPC UA and how they approach that technology and why they are interested into integrating this technology into their systems. Does that answer that question?
Hi, good morning, Tobias. It's easier to unmute and discuss. Yes, I think the word embrace meant, willing to collaborate and work together. OEMs often have proprietary systems that is a value add service for which companies have to pay, and they are very protective around, the framework and the communications structures that they use. So it's good to hear that they are willing to, collaborate and have a wider integrated system. And then we'll move away from a single equipment or manufacturer-based supply or fleet. It's transferable between different brands or OEMs. So thanks for that.
Yes, also, if I may add, they already see the benefit that when they create the structure and the way to communicate, that even if the other partner doesn't necessarily at the first stage use OPC UA, it will be very easy to, through the definitions of the language, to cast that into any other system. So they won't be as busy anymore with when they have a new partner with specifying their interfaces and discussing data types and definitions and structures of the data. Since they have done that once and written down and documented, that will be then just like a using manual to integrate their to their machine. And that's also like an open manual that is based on a worldwide standard. Thank you. Thank you for your question.
I have a couple of other questions. Hi, Tobias. Most of your examples here are for open fit on the surface. How much progress have you made for underground mines?
For underground mines, as I will present, as I will present later, we will integrate the IRIDIS standard, the International Rocks Excavation Standard, and we are cooperating with the IRIDIS standard to integrate IRIDIS into OPC UA, which will give us a pretty good head start and make also a head start in the underground mining with all the IRIDIS use cases. And also it will make the IRIDIS data, on the other hand, a lot more available. So we are already cooperating with other standards, and we are very would welcome you if you know any standards we could incorporate, anything we could integrate. We would welcome you to talk to us.
Okay, I have one more question. Could you name some OEMs who are already using OPC UA, and what are other communication protocols that OEMs are currently utilizing?
Thank you for the question. I would actually come back to that question on the last presentation, since we have prepared a slice a slide for that with a list of OEMs that cooperate on the design of the companion specification, and we'll come back to this at later point in time. Is that all right?
That's great. Thank you very much.
Thank you. Okay. So when that's it, then I will stop sharing and hand over to Dr. Fiona Mafroudis. Thank you.
So hopefully everyone is hearing now. Okay, yeah, hello everybody. My name is Fiona Mafroudis. I'm the head of application engineering here at ICOV. Yes, first of all, thank you very much for giving me the opportunity here to share with you some thoughts regarding interoperability in underground mining, and more specific OPC UA as a common language for the mining applications. I would like to begin or present a little bit more about the machine overview and the interconnection in the underground mining, and therefore I like to begin with some information about a company, the ICOV holding. It is a family business. It was founded in Bochum back to 1864. And it's still managed by the owners in the sixth generation, with a turnover of around 40 million euros. So in totally, we employ around 1,060 people worldwide, 1,030 in Germany, and 300 in daughter companies around the globe, with a location, for example, in Australia, China, Russia, South Africa, and the Belarus. Yes, so ICOS was emerged from the former iron foundry into a high-tech group of companies consisting, as you see here in the slide, industrial gearbox and wind turbine technology, the casting technology, machine technology, and of course the mining technology. So regarding here, the ICOV mining technology is focused on the design of special machines exclusively for the underground mining. So we're talking only about machines for underground mining with two types, one of the shear loader and the longwall mining, and the continuous mining miner for the room and pillar. Yeah, now I'd like to share some information regarding the shear loader for better understanding for the overall context, and it makes easier for me after to have a transition to the OPC UA topic. So yeah, regarding the design of the shear, it's basically a classic example of special machine engineering. So from a modular system, depending of the geological requirements, we supply various series for the different applications. So each machine is a unique, it's a tailor-made, it's adapted special to the wishes of the customer. So these underground machines have an operating range of 1.2 meter and until to 8.5 meter, and a power input for the 80 to 3,000 kilowatts, making millions of tons of coal in every month. These machines are also equipped with a lot of sensors, also advanced sensors for geological and geometrical recognition. For example, we have radar sensors in national navigation, we have cameras, and also simply sensors for temperature, and all that in order to fulfill the high level of automation that we already have in some mines regarding the automation and of course the remote control operation. Yeah, and this shear is also fully integrated into the mine infrastructure, so the shear is not operating on its own, is integrated in the underground mine and is communicated with other longwall equipment. At this stage, basically, we use different interfaces to external systems as UPC, Ethernet IP, and Modbus TCP. We have a big focus on mining 4.0, but here we not look to transfer the industry 4.0 objectives to the mining, but we are rather thinking of an advancement of automation in the complete process of mining, including the extraction, the transport, and the processing. So if you look now at the overall system during the underground cutting, as I said before, there's a constant interaction and collaboration between the various components. So you can see that here in the slide. The shear loader in the middle is constantly communicating with the conveyor and the support. The information, for example, as a conveyor loading, shear location, collision risk, and other process data is exchanged and then sent to the control station and also the control room in the surface of the mine. And after the shear passes through, we have automated processes happening there. The shields are set automatically and the conveyor is moved. So already the shearer is able to operate remote and autonomously in this very extreme underground environment. But the basic equipment always are standardized communications that are independent of the manufacturer, and of course our robust data transmission systems. So in underground mining, we talk, or in the longwall mining, we talk about a horizontal and a vertical machine-to-machine communication. At this stage nowadays, the human factor underground is mandatory, but when looking to the future, we definitely need to rethink how the equipment and the technology that we are now use for automation and up to data analytics and process and how we use that. So in the near time, I believe we want to have underground machines operators, and but we will have a longwall operator that configures the entire system based on a common language from the surface. And now we're coming a little bit closer to the OPC topic. I'd like to share to you this information just to have a better transition to that. And in order to align with our roadmap and be prepared for these future applications, we redesigned the ICOF software framework as a modular object-oriented machine software that basically reflects all the real structure of the machine. This software framework is nowadays based on the Codesys development environment. The single models, the map, the hardware and the functionalities, and of course after the metadata, interfaces, field bus devices, input-output assignments and be made. And the machine that can be configured and assembled of the desired models with all the relevant parameters. And due to our decision that we're generating the code, or the generated code to include all the available aspects in the modules, this generate code requires basically no more changes. And our development is, of course, now based on agile software development with Scrum and Kanban methods. Now that you have some insight into the all-over context from our point of view, from shear loader and to the underground longwall mining, I like to explain a little bit our motivation for OPC UA. So why OPC UA? As I already explained or mentioned, the already implemented object-oriented approach within our software framework. And of course, this future vision of the mining industry with connecting the machines and the systems and the entire mine wide level motivated us to look a little bit closer to this communication stack for the internet-based communication called now OPC UA. So for us, as I said before, mining 4.0 means the use of new technologies to connect and to communicate the sensors, the machines, the systems, and also the people. And the OPC UA communication stack defines the language and which these machines can exchange the information within the mining 4.0 approach or context. We also believe that the early participation and the co-determination of the standard is now very important, and maybe also provide some advantages in terms to innovation or in terms to competition and time to market. We already found the exchange between the participants, the OEMs and the operators for very fruitful as new ideas, solution discussion, and at the end user cases have been discussed and drawn up. And of course, not to forget the technical aspect that Tobias already mentioned is important here. The object-oriented approach was already mentioned before from my side. The OPC UA as a platform, independent and scalable, enabled to integrate the OPC interfaces directly into the systems running on many different platforms. And of course, the TCP/IP-based architecture that makes the routing and the internet connection to the firewalls possible out of the box. And of course, not to forget the implementation and the configuration within the control system is possible without high effort. And at the end, in addition to all this functional specification, we also experience the influences from the industrial and as from the customer environment regarding OPC UA that brought us nearer to the topic and to get a closer look on this communication platform. So with the next slides, I would like to give you just a short example of the implementation of OPC UA within our codices application composer and the object-oriented structure in order to give you an impression, but really out of the bird perspective, how simple implementation can be done. So what you can see on the left side is structural model tree, and as example, the ranging arm as a component of our Shearer loader and respectively a model. So every model has these properties, the methods and the specified interfaces or references to the other models. As you can see, the clear definition of the properties and methods, and the communication between the models happens exclusively via the interfaces. So the interfaces can be used even before the class has been programmed, and also now allows parallel development. So the advantage now of the small OPC UA server stack is now that the possibility to include this directly into the runtime of your control system and thus have a direct access to variables by OPC UA through a client. And at exactly this example, you can see here out of our application composer generates a list of variables, and that means that for us, the OPC UA is integrated into the codices, runs directly in the runtime of the controller. And as we said, it's independent of the operating system, thus it runs also on Linux here, for us important. So the control system generates automatically an OPC UA interface, and we have a direct transmission between controllers and sensors. It's easily and possible. So it's a uniform one-off defined communication. No separate configuration is necessary. So here you can see exactly the information that's coming out of our object-oriented structure, and then you can find the same variables here that can be accessed via OPC UA client. So from us, just a sort of summary to that, the OPC UA is a data exchange for us, very secure, reliable, and manufacturing platform independent industrial communication, and enables a cross-operating system and data exchange between products of different manufacturers. So we as ICOF are committed in the cooperation in the mining specification for OPC UA. This specification is developed in very close cooperation with within and between the manufacturers, the users, and the research institutes, and of course the operator, in order to have a standardized data exchange with with all the external systems. The conversion will be done directly into framework library and will uniformly be available on all machines, bringing now advantages or bringing advantages in the future for the ODMs and the customers due to the less coordination effort. So it's scalable, and it also has all the advantages of depth services and integrated security and data modeling. So I like to close here my short presentation, but I hope I have managed to give you a little bit of a brief overview and a better understanding. And I believe Tobias also will present the work or the kind of the work and the groups and our efforts that have been done so far in the mining working group. So I thank you very much for your attention, and yeah.
Do we have any questions for Fiona?
Okay, one just came in. Is there some relation between OPC and ERP?
Yeah, that's basically a good question. I'm not sure if Tobias will explain a little bit more later on. ERP, as I understand, we also use ERP as a communication. I don't see, or I don't believe, a direct connection to that. But of course, there are some communication protocols that also can coexist. Yeah.
If I may add to that, we actually start now looking into this topic more closely. Like, what does the process and the automation and the resource planning of the entire mining need, and what do we need to communicate to whom at what point in time? And we're actually looking at that right now in an ongoing development project. So yes, that's a very interesting question, and something we will look at in the future, how to integrate and who needs to know what to have an optimized resource planning.
Oh, I'm sorry, ERP, I didn't understand, didn't hear it right. Okay, yeah.
So I have a couple of other comments here. ERP systems like SAP usually do not, it's moving quickly, usually do not support OPC UA out of the box. And then another question underneath that, do you integrate only with OPC UA to external systems, or do you also use other solutions such as REST or similar?
Yes, also other solutions. At the moment, we do not use actively the OPC UA. It is integrated and possibly thought for the future, because of course we have some issues also with the OEMs on the controllers on their side. Yeah.
Okay, and one more question. Any other underground autonomous machines that ICOF is working on?
As I mentioned on the beginning, we have the two products, the Shearer Loader. I choose that as an example that is more or less more integrated in the autonomous process. But of course, also the other product series of the continuous miner is also integrated in the underground mining in a kind of automation process.
Okay, great. Those are all the questions for now.
Shall I hand over?
So thank you very much, Fiona. I think that is a great example how you can participate in the companion specification, get out some standardized modules and standardized communication, but on the other hand, utilize OPC UA straight away to make your data of, in this example, the Shira, data and services of the Shira and all the modules available through that system, and be able to map these object-oriented structures straight into that communication language. So now I would go ahead and tell you a little bit about the progress we have in the creation of the OPC UA for mining, the progress in the working groups. That is, of course, work in progress. We wanted to use that chance to present first results and give the GMG and all of you the chance to have a look at what we do and how we create that object-oriented language. So if we talk of mining, as I said, it's very heterogeneous. It's a large variety of machines and machineries and processes. How can you write that into a specification? And that was the thought we had before we started with OPC UA. And how can we bring this into a specification? So what we first did is organize the mining into some landscape and try to gather and organize the processes in our mining landscape. Of course, there can be some other ways how to organize, where we try to, as good as we could, organize all bits and pieces and define different sectors that we could then address in our specifications. And as I already mentioned, for the drill and blasting sector underground, we will include IRIDIS, and that is already shown in here. So from that organized mining landscape that we took as a foundation and went into discussion with our partner, or with the partner OEMs, or with the VDMA OEMs. And when we had that set and get a little head start, we then had the official start of the Companion Specification in October 2019. So we are not too far in yet. And what we do right now with the OEMs is the identification of the use cases in the mining landscape. So where are they in this landscape? Where do they find them? And what is the actual application they would like to automate next, and what applications and what data and what types of machinery do they want to make available through the system? And then from that, we actually specify the objects of the machinery or of parts of the machinery. And then we have to move on and also define tests and define test cases, how we can test our interfaces with actual hardware or in simulation, before we then can have a release candidate of the Companion Specification in spring 21. That's our goal. So as I said, we organized the mining in the mining landscape, and then we went ahead and picked use cases from the mining industry, from the partner incorporating OEMs. They then started working on the use cases within the mining landscape as they wanted to, and incorporated on that in already a few workshops to identify the use cases. So what is a use case? When we think of a mining process, then a use case specifies some piece of that process that you would like to automate. For example, I take the truck and shovel again, the truck filling, the shovel filling the truck, or then the truck going ahead to the crusher and emptying at the crusher. Those machines need some kind of interaction, and this is what we call a use case. And then we went ahead and analyzed the process of the use case. We know that those machines have a huge list of available data, but through the analyzation of the process, we could identify not only the partners that go into interaction, but we also could find out what information does who need to have that process automatically running. For example, like when humans operate, you often hear them honking, and that is some kind of communication that when there is no operator anymore, then you would replace that by maybe a status change and say, hey, I'm full, or hey, you are full. And that way we analyze the process, identified what information do we need to, does the partner need, what do we need to share? And based on that, we started modeling the machine objects. And with that, in that way, we avoided to just define a lot of so far unnecessary parameters. So through the analyzation of the process, we already gained a lot of fruitful discussions about the automation of the process and about the data and the data structure of the machinery. And then actually the manufacturers in the group start rethinking the things like they are used to doing them. And then based on that use cases, we take, we summarize all the statuses, all the information from the processes and use cases that we need. And from that, we create and structure the so-called types that are the objects within the for the OPC UA. But that could be, of course, an object that could also be used in some different object-oriented communication. And then also what we are going to add is some use cases for the supervision of the machine. So what does a command control system needs to know about the machine, and what information does it provide into the vertical direction, the vertical integration. So after we have specified the object, here I've created like lines to see where we are. This is the state, how far we are right now. And this already helped us to get the context of our doing and get a certain understanding. And it was very interesting to also see the OEMs sitting together, like experts for shearers and shields and conveyors, sitting together, discussing about what information do they actually need to exchange to have that process going. And then they could summarize the whole shearer application use case, that they only need like 6 or 7 sets of data that they need to exchange once in a while, and need to maybe supervise each other a little bit, but else it's all in the reliable responsibility of that machine that is that the manufacturer provides. So the use cases help us describe the machines and describe the functionality and get an overview and the larger context. When we then go ahead and define the objects and the structures of the objects, we realize what we need, how we have to organize those objects into subtypes and supertypes. And then we can also go ahead and harmonize those objects with different companion specification. For example, there was a lot in the robotics, from the robotics we could learn for the mobile machines, and we're taking harmonizing a lot from there, and also other amendments that are already existing. So what's up next? Next we will need to validate our use cases, finish defining our profiles, and come up with some test scenarios to test our communication in simulation or with actual hardware. I guess that's the OEM's task to figure out how to test best. And then we will go ahead and start picking up the next use cases. And of course, at this point, I have to invite you to participate and fulfill the gaps of the use cases, and cooperate with us together to create use cases within that mining landscape. And when our groups finish with their first use cases, then of course we keep iterating till till time runs out and we have to hand in the first version of the specification. That will, of course, leave a lot of room for other use cases, more applications, since mining is such a huge and various industry. So we had the question about what companies are participating, and this is a list of the participating companies so far. We do have some working groups that are very active. Some companies just join, listen, and get their ideas and are discussing and might join later as we progress. But yeah, we are also progressing in our methods and yeah, how to move forward in creating that kind of communication. So here we would like to invite all of you to be part of the first version, and we only can get like the most value from this setup and all of our doing if we all participate and we get as much stakeholders as possible together to create the whole value for the mining industry and define our common language. The next web meeting will be going on next week, so very closely, and I have to excuse myself or excuse us that we have such an early morning time, but we have people from Australia joining, so we thought we'd go for the morning, and we didn't know that we go for the North and South American time frame. We would have this meeting and presentation. So yeah, thank you very much for listening. Thank you very, very much. And I'm looking forward to your questions and also to your contacts and afterwards, and to you joining us in our work and helping progress a common language for mining. Thank you.
Thank you, Tobias and Fiona and John, for the presentation today. We have some questions on the chat. Maria, maybe you can read it over.
Sure. Okay, I'm going to start first with a comment from Peter Clement. There are integration products in the market that talk OPC UA, REST, MQTT, and other protocols. A question after that, what other protocols are in competition to OPC, and how do you see this standard? What is the percentage adoption at this point and the forecast in the future?
First, we have that question, what other protocols we have. And many OEMs have using proprietary protocols with their smaller systems that they integrate, some bus systems, but also we have people use Ethernet IP, which could be a very, which has also a lot of features that make it very interesting. And it's also one possibility to use. I think the largest difference to the Ethernet IP is the structuring of the data. I mean, in Ethernet IP, you can create some kind of data structure and definition, but the advantage in the OPC UA is just the deeper structure that you can create. You can basically recreate your machinery in that language, and then have a shearer with the left and right arm, and the arm also with the motor, and then restructure your objects in that way. And I think that is one large example. Or we have the Modbus that I talked about earlier, that is but more bonded to hardware and other protocols, but you could also use that in combination with OPC UA. As I said, it's more or less a toolbox that you could use. You don't even have to use the entire all the layers. It just offers it, and that way it makes it attractive to maybe create some parts in OPC UA and keep existing parts and make them more secure or more interoperable with what we had. And what was the second?
Yeah, just one comment from my side. Also, I agree with Tobias. We also use an Ethernet IP. It's very strong in our application. And I think a big advantage of OPC UA is also the data modeling in itself. And of course, I think even OEMs can keep proprietary protocols themselves, and that they can also coexist. And it isn't always fair to compare QTT, let's say, protocols with OPC UA. It's more or less also for let's say, maybe specific to each application, while OPC UA is more, more for the industrial environments and more looking up from the bigger picture. Yeah.
Yeah, there was a second part to that question, and it was, what is the percentage adoption at this point and the forecast in the future?
And that is a hard question. Björn, what would you say? What is the percentage of the adoption? We are very early in the writing the specification, and people are using first use cases. We are also integrating it now together with some partners in development projects. But regarding the mining industry, it's a very low. But other industry are using OPC UA for a longer time. Do you have any numbers on that?
No, I have no numbers at the moment. I know we have some other associations or branches which have already released their companion specification, and I know about some mining companies that uses OPC UA, for example, for some use cases and solutions, but to say we have a percentage of 5, 10, or 90%, I think it's too early for the mining industry at the moment.
Yeah, I already know also some partners that just use it without having a companion specification out, because they just say it's very easy to cast all their objects and integrate it and get a communication going. But
okay, the next question is, do you think that OPC UA can be the driver to facilitate mine-to-mill integration? Mostly mine-to-mill is difficult because mine equipment cannot communicate easily to plant equipments and DCS PLC, or that integration can be managed with only PIMS such as OCSoft PI.
Yes, I think so. I think if we spread out that standard, we actually can get mining and processing closer together, and that can create like a larger value. When you know what's going on in your mine, you will be able to adopt your processing, and that is, of course, a very important point. And
well, I do have a comment here from Peter Clement. Even in manufacturing, there are multiple protocols, including OPC UA in the supply chain, so would expect a similar scenario in mining. The Industrial Internet Connectivity Framework of the Industrial Internet Consortium shows a way how to architect connectivity in a multi-protocols world. There's more questions. How could we participate in the development of OPC UA in mining?
Oh, it's really easy. If Tobias will go back one slide.
Yeah, hold on.
And we will have a QR code where you can, which lead you to the website for the web meeting, so you can register there. And it's free for all stakeholders who wants to develop OPC UA with us, and you will warmly invited to develop with us in our workshop the common language on OPC UA.
Just sign up or contact one of us, and we'll be glad to help you, and maybe also give you an idea where to start with, what to start with, the experience we have from our partner OEMs.
Okay, I do have one more question. Domenica, do we have time for one more question?
Yes, let's just finish up the ones that we have.
Okay. How does OPC UA scale? Should it be used for individual sensors or to represent the full assembled product? Does it clash with other protocols when running on the same network hardware? How do you communicate the available data points to other participants? For example, send them XML files with the data points.
Okay, that's a long question. Yes, it scales. You can use it for some small, tiny parts in your machinery, or single motors or whatsoever, and then those parts can be part of the larger machine object, or even or like a shearer. The shearer motor can be part of the arm, and the arm is then part of the shearer. So we have the full object-oriented approach. And let me see. And of course, it can run on together with other protocols on your network. It just makes use of the same lower levels as other protocols on the network, and goes onto the network traffic. But it is very slim, and there are studies out that OPC UA has very quick performance, but also can transport also lots and larger data streams, and is quick and very potential in doing so. And regarding the XML files, Iridis, for example, is using the XML files, and you could go send them straight away via OPC UA, or you could first cast them into OPC UA objects and then make them available in some different system with the structure and object orientation of XML. That should be no worries.
Okay, those are all the questions that we have.
Thank you so much, Maria. So thank you all the participants for joining today. Thank you Tobias, Jorn, and Fiona today for this great presentation. For those that were here on the call, please note that we have recorded the session, that we will make this available in the YouTube private channel of GMG. So we will be sharing this recording along with the presentation as soon as this call is over. So please expect an email in the next couple of days. Also, if you want more information, please go ahead and check out the VDMA. So if you want to get involved in this working group, please go ahead. And then thank you all for participating and hope you have a great rest of your day. Thank you.
Can I ask one more quick question? We have someone asking how to register for the event that was discussed, OPC UA on May 13th.
Yes.
The one that's right here on the screen right now.
This QR code, or if you want, get in contact with us, Tobias, Fiona, or me, then we would just you for the meeting on the 13th.
I'm going to share, Jorn, if you're okay with it, your email on the chat.
Yep, no problem.
There you go. So please copy this email, and you can send an email directly to John, and he will send you all the details about the call and how to get involved in this project. Great. Thank you all. Hope you have a great rest of your day.
Thank you very much.
Very much.
Thank you.
Thank you.
Bye.
Bye-bye.